An atom is the smallest part of an element that still behaves as an element. For example, an atom of oxygen still behaves like oxygen even when you've pared it down to just an atom. Now, atoms come in three parts, three subatomic particles. The first one is the proton. It has a positive charge and it has a mass. We say that it weighs 1 atomic unit, or AMU. An AMU is basically defined as the weight of a proton. On our diagram down here to the right, the proton would be in the center of the atom as a part of the nucleus. Neutrons are also a part of the nucleus, and they have a charge of 0. They weigh the same amount as a proton, 1 AMU. Together, the protons and neutrons in a nucleus give the atom its atomic mass, or atomic weight. The protons by themselves give the atom their atomic number. It's the number of protons that tells you how the atom is going to behave. For example, hydrogen has just 1 proton. That's why it behaves like hydrogen. That's why it's a gas. That's why it's highly flammable. Whereas oxygen has an atomic mass of 8, which gives it its characteristics that make it valuable for us to be breathing. Now, around the outside of the atom are the electrons. The electrons have a charge of a negative charge, and they're small enough that for the purposes of this class, we're going to say that they have no mass. They circle the nucleus, and they are what gives the atom its chemical properties, how it behaves when it gets with other atoms. In this next section, we're going to talk about bonds and attractions. We're going to talk about ionic bonds first, then covalent bonds, of which we have 2 types, nonpolar and polar. Then we're going to talk about hydrogen bonds and hydrophobic interactions. In this slide, we're going to talk about ionic bonds. But before we do that, let's talk about the arrangement of the electrons around the nucleus. We only have to worry about 3 orbitals. They're represented about by these lines around the nucleus. It's kind of like satellites orbiting a planet. And for this class, we only need to worry about the first 3. Now, you'll notice this first orbital is kind of small. Only 2 electrons will fit in that first orbital. In the next 2 orbitals, 8 will fit. And all atoms, if you want to give them human emotions and wants, want to get up to full orbitals. It's kind of like playing 21. The closer you can get to 21, then you're closer to winning. You're more likely to win. So let's take sodium for an example. This figure represents sodium. It has an element number of 11, which means it has 11 protons represented by this green nucleus. Now, around the outside, we can get 2 electrons to fit in this first orbital, and it's full. Then we have 8 electrons in the second orbital, and it's full. Then we have 1 left over. We've got 1 electron in this orbital, and that's not really a comfortable situation, okay, because sodium's not going to go out and get 7 electrons. It's just not going to happen. Now over here we have chlorine. Chlorine has an element number of 17. That means that it has 17 protons represented by the yellow nucleus. Now in the center we have 2 electrons in the center. Okay, that orbital's full. We have 8 electrons in the second orbital. That orbital is full. Then we have 7 electrons in the third orbital. It just needs 1 more. Okay. Now the more stable configuration would be for sodium to lose that extra outside electron and for chlorine to pick up 1. So what happens is chlorine takes that extra electron from sodium. Now it has 1 more electron than it has protons. That means it has a negative charge. Sodium has 1 fewer electrons than it has protons. That gives it a positive charge. Okay? Now, anytime an atom has either more or fewer electrons than protons, we call it an ion. Okay? So an ion is an atom that has a different number of electrons than protons. Okay? Now, positive ions are attracted to negative ions. Okay? They hang out together. Those charges attract each other. Okay, here's another way to think of it as in a schoolyard example. Big old mean chlorine has come and beat up poor little sodium and has taken his lunch money. Okay, so now chlorine has more money than it should, and sodium kind of follows around, hoping that he's going to get his money back. Okay, now we have a name for the different types of ions. A positive ion is called a cation, and a negative ion is called an anion. Let's talk about atoms that are kind of medium-sized. They're not big enough to steal from other atoms, and they're not small enough to be giving up electrons to other atoms. Let's take hydrogen for an example. It actually is quite small, so it fits in the can be stolen from category, but it has an atomic number of 1. It has 1 proton, and it has 1 electron. Now, it would really like to have 2 electrons in its outside orbital. So what it does is it gets together with another hydrogen and they share the electrons. They go zipping around both protons. We call this a covalent bond. Okay. And we represent this as a single line between the letter that designates the element. Or we can show it this way with the lowercase 2 indicating that there are 2 hydrogens. Okay. Let's look at when we are combining atoms that are different. For example, carbon has an atomic number of 6. So we have a full electron orbital around the inside, and we've got 4 on the outside. Now, carbon would like to have 4 more. It's big enough, it's not going to give up those 4 electrons, but it really can't take 4 electrons from another atom. So in this case, 4 hydrogens got together. Remember, they want to share 1, and they get together with carbon, and each hydrogen is forming a covalent bond with the carbon. And this produces methane, also known as swamp gas. You'll notice here we're showing a single line to show where each pair of electrons is being shared. Let's talk about water. Water, as you may know, is 2 hydrogens bonded to an oxygen, H2O. Oxygen has an element number of 8. That means it has 6 electrons in its outside, or valence electron shell. It wants 2 more electrons. Hydrogen wants 1 more, so the 2 hydrogens get together with the oxygen and shares with the oxygen. Now, because oxygen is bigger than carbon, it can keep the electrons a little bit longer instead of stealing them. And so what happens is the electrons zip around hydrogen once, twice around oxygen, once around hydrogen, twice around oxygen, once around hydrogen, twice around oxygen, so that what happens is the molecule gets a slight positive and negative charge. Oxygen gets a slight negative charge because the electrons are spending more time around the nucleus of the oxygen, and the hydrogens get a slight positive charge. We call this a polar covalent bond. Think of it as the poles of the Earth. The Earth is a big magnet, and it also has a negative pole and a positive pole. Now, because water has a positive and a negative side, if you will, positive and negative pole, it forms bonds with other water molecules. The negative oxygen is attracted to the positive hydrogen, and so on and so on. And we call these hydrogen bonds. Don't get confused between the bond, the covalent bond, the nonpolar covalent bond between 2 hydrogens in gaseous hydrogen, and the hydrogen bond between molecules. Now, hydrogen bonds can form between any molecules where there is a hydrogen bonded to an oxygen or a hydrogen bonded to a nitrogen. Those are the ones that you need to worry about for this class. Now let's talk about what happens when you mix water with molecules that are not capable of hydrogen bonding. Here we have an example of a string of carbons, non-polar covalent bonds between the carbon and the hydrogens that are attached to it, and we have a bunch of waters. Well, the waters, because of their polar covalent bonds, they've got the slight positive and slight negative charges. They're attracted to each other. So this one comes over and says, hey, I can form a hydrogen bond with you, and it's all happy. And this one over here is saying, oh, well, don't leave me out of the party. And the carbon molecule is saying, hey, you're stepping on my toes. And it keeps getting more and more crowded. Hey. And it can't form hydrogen bonds with the water because it doesn't have an oxygen bonded to a hydrogen, nor does it have a nitrogen bonded to a hydrogen. So what happens is it's excluded by the water. Now we call this hydrophobic interactions. Molecules that are incapable of forming hydrogen bonds are excluded by the water that wants to hang out by itself. Okay? Kind of sounds like cliques in high school, doesn't it? Now, molecules that can form interactions, hydrogen bonds with water, are called hydrophilic. Philic meaning loving, hydro for water. So they're water-loving molecules, whereas molecules that are excluded by water, that can't hydrogen bond, are called hydrophobic or water-fearing.